Hello, everyone. Welcome to Consilium. My name is Lisa Sipenko, and I head Consilium Scientific. Today, we have with us Professor Jim Tabery from University of Utah. I got to know Jim a couple years ago when his book came out, Tyranny of the Gene, Personalized Medicine and Its Threat to Public Health. It was a very fascinating read, and I was planning to invite Jim for a while. So I'm very pleased to welcome him at Consilium. And Jim is a philosopher who is focusing on science and medicine and bioethics. And his knowledge of healthcare policy and healthcare field is absolutely impressive. So fantastic book. You can find it in our library. You can find it on Amazon. But I'll give a word to Jim now to take us through what he's learned in the journey where he thinks things are right now with personalized medicine. Jim, the floor is yours.
Thank you, Lisa, and thank you, Consilium Scientific, for this invitation. I'm really excited about the opportunity to chat about this with you all. My plan is to speak for about 35, 40 minutes tops, and then make sure that we've got 20 minutes or so for discussion at the end, because I'm really interested to hear what folks have to say. Just to sort of introduce this by way of its relation to the book that Lisa kindly mentioned. What I'm going to be talking about today was basically there was a germ of this idea in the book. And I didn't go into a great deal about it because when I was writing it, it seemed to me that it was just obvious and there wasn't a whole lot that needed to be said. But what I found is since the book came out about a year and a half ago, this idea is the one that has sort of generated the most discussion and got the most pushback and is, I would say, most likely to make people yell at me. And so given that, I thought this would be a great opportunity to sort of expand on these ideas, push them a little bit further, and kind of try to make a further case for why I think this is in fact what's going on and how we should see the situation. And so basically it stems from what I can think of where we can start thinking of it as a puzzle. And so the puzzle looks like this. For 25 years or so now, a genomic revolution has been purportedly coming to healthcare. When you look at how that genomic revolution is packaged for the public and for scientists, you find two names in this space, two terms for describing it. On the one hand, and those books that I list on the left are examples of this, it will be called personalized medicine. So what genetics and genomics brings to healthcare is the ability to deliver personalized medicine. On the other hand, you can see just as many, and in fact, perhaps more now, references to calling it precision medicine, where the idea is what genomics and genetics brings to the healthcare, or what this revolution is going to bring to healthcare, is the ability to deliver precision medicine. So we've got this one revolution, these two names are out there. When you start looking, though, then for what is the nature of the relationship between personalized medicine and precision medicine, you find all sorts of different characterizations of this. And so I've just given you some examples here. You can find people say that it's sort of a set-subset relationship. Personalized medicine is this overarching thing, and then within personalized medicine, there are instances of precision medicine. You can find temporal ways of carving up the field. As you move through healthcare, you're going to start with personalized medicine, then at some point they're going to transition you to precision medicine. You can see it characterized in terms of who is the person involved at any given moment. So when a clinician's doing it, then you've got precision medicine. When the patient is thinking about their relationship to their own DNA, that's the personalized medicine. You can also find all sorts of other different ways of sort of carving this up. I've heard it divvied up between germline and somatic mutations. I've seen it divvied up between different clinical processes, different biological processes, all different ways of trying to impose some order on the fact that now we've got these two terms that are supposedly about the same revolution. And then finally, the last bullet point that I list, you'll also find people just say they're synonyms. These are two terms for the same exact thing, namely this genomic revolution in healthcare. And so this is the puzzle that I want to just kind of motivate for the talk with you all today and try to answer, which is what's going on here? How did we get to this point where this thing that was sufficiently characterized as genomic medicine now has these two additional ways of packaging it? And because there's more than one way to package it, there are all sorts of different interpretations about what the relationship is between these packagings. And so this is really it's a story. It's a story about the last 25 years of medical genetics and how what was just basically straightforward pharmacogenetics morphed into this thing called personalized medicine, which then again morphed into this thing called precision medicine. And the real take-home lesson is going to be how there was this moment about 15 years ago where the medical genetics community realized that kind of using marketing lingo to convey to the public what's going on in genomics can create all sorts of confusion. And rather than seeing that as a moment to step back from marketing lingo to characterize medical genetics, they just opted for swapping out one marketing lingo with another one. And as a result, what we've now got is a whole lot more confusion than we even had 15 years ago, and certainly more than we had 25 years ago. And so that's the kind of story that I want to tell you. So here's how I'm going to move through it, basically chronological. I'll start with where this concept of personalized medicine first came from, sort of the instance where it emerged and then how it exploded out onto the healthcare world for about a decade. Very quickly, though, from that arrival, people started raising concerns about the personalized medicine packaging. And so there was an effort made to try to get away from that confusion that was coming along with personalized medicine. And what gets offered in its stay is precision medicine, and that's part 3. What I'm going to try to convince you of in part 4 is the very same problems that were raised about personalized medicine, the things that got people thinking, hey, we need to step away from this concept because it's actually doing more harm than good, has happened in precision medicine as well. And so that takes us to the final section, which sort of surveys the current landscape we live in, where both of these terms are floating around together, and it's an absolute mess. And so I'll try to sort of convey to you how it's an absolute mess and make a recommendation for what to do about that. So let's start with the origin story here. This is a sort of the short story that I tell in a portion of Tyranny of the Gene. Personalized medicine grows directly out of pharmacogenetics. If you're thinking of the history of pharmacogenetics, you could go back, depending on how you want to count, decades, even centuries. I think the galvanizing moment happens in the 50s and 60s when people in pharmacology and people in genetics come together and realize that they can work together primarily to try to avoid adverse drug reactions. The gentleman on the top there is Arno Matulski. He's a medical geneticist, or was a medical geneticist at the University of Washington in the United States. And he was the first person that sort of made the case for this science of what he called drug idiosyncrasies, but basically using the tools of medical genetics to figure out why some people have bad reactions to drugs and other people don't. Pharmacogenetics as a concept and a discipline is out there for several decades, 50s, 60s, 70s, 80s. It's really not, though, until the late 80s into the 90s when genetic research on the cytochrome P450 gene and all the enzymes associated with it that are involved in drug metabolism explode. That's Daniel Nebert next to him, who did a lot of that research at the NIH. That pharmacogenetics moves from this sort of academic-y thing that some pharmacologists and medical geneticists at universities are interested in to being a discipline, and in particular, a discipline that the pharmaceutical industry is starting to take notice of. And so what happens in the 90s is a lot of sort of medical geneticists who are largely academics at that point start making a real push to get their ideas in pharmacogenetics built into major pharmaceutical companies. And the promise is this kind of win-win-win option that if you're using genetic information about patients to figure out who's going to have a good and a bad reaction to a drug, to develop new drug targets, is a win for everybody. The drug companies do better because they're going to be more successful at developing and testing new drugs. Hospital clinical world is going to do much better because there's less trial and error in terms of throwing things at patients that we don't know whether or not their bodies are going to be able to handle. And then patients benefit because they're going to have fewer adverse drug reactions. That's the promise of pharmacogenetics. In this period in the late 90s, though, as there's this effort to take this science from, again, sort of the halls of universities out into the world, whether that's to patients or reporters or politicians or drug companies, the pharmacogeneticists realize that they have to package this in a way that will sell it. And so what we find are these three phrases that start to take hold in pharmacogenetics. One is an explicit contrast. The contrast is with what they call one pill fits all pharmacology. And so the idea is, before pharmacogenetics came along, anybody has diabetes, you give them the same pill. Anybody has high blood pressure, you give them the same pill. It's a one pill fits all approach. But what pharmacogenetics is going to bring takes us down to the second phrase. It can deliver the right drug for the right patient at the right time. And so it's this contrast between this sort of boogeyman of one pill fits all and the revolution of right drug for the right patient at the right time. The last phrase that really catches on, and this is introduced by that gentleman on the right there, Gualberto Ruano, who was a medical geneticist at Yale and in Connecticut. He was basically developing a new company, Genescience Incorporated. And the initial slogan that he had for it was pioneering pharmacogenetics. That's what he wanted to do. He wanted to bring pharmacogenetics out into the world. But he realized that the average person on the street and the average investor has no idea what pharmacogenetics is. And so he comes up with the idea of pioneering personalized medicine. He is the one who gives it that packaging to say, this is what pharmacogenetics brings to the table. It personalizes medicine. And I include that quote from him. That's when I spoke to him about all this. This is sort of what the explanation that he gave me about why he opted for pioneering personalized medicine instead of pioneering pharmacogenetics. He says, it's a slogan. It's about mass appeal. When you're speaking to a general audience, the question is, how catchy will it be? And so that goal of introducing something into this space that's catchy was the real motivator at this point. And it turns out it was really, really catchy, right? Ruano introduced it simply as a slogan for his company. But in the decade that follows, this terminology of personalized medicine absolutely explodes. You now suddenly have new journals coming along. Sometimes these are new journals entirely, like the journal Personalized Medicine. In other cases, they're just old pharmacogenetic journals that now realize, oh, it looks like personalized medicine is how people are talking about it. So they sort of rebrand themselves as personalized medicine. When you look at that first decade citations in PubMed, just a couple in the late 90s to hundreds every year a decade later. We get lobbying organizations that are sort of making the case for bringing this idea of personalized medicine out into the world and lobbying governments to make the regulatory landscape more user or more pharmacogenetic friendly. And then also lots of conferences start popping up, World Congress of personalized medicine meetings. I gave you that little diagram at the bottom. That's a Google Ngram. So that's just for books. But if I did the same thing with PubMed, you'd see something very similar. It runs from 1990 all the way on the left till I took it out to 2010. And what you can see is sort of virtually no references to this thing until you get to about 2000. And as soon as you hit 2000, they just start spiking. So what happens here is because personalized medicine is really catching on, this idea of a bandwagon effect kicks in, where basically anybody in the genomic medicine business now wants to be able to say they're doing personalized medicine too. And fortunately, those three phrases that I mentioned to you earlier didn't have to morph much to make that happen, right? So it starts in pharmacology with one pill fits all. Well, you could just shift that to one size fits all. So now the contrast, the boogeyman that is sort of thought of as the thing that the revolution is undoing, isn't one pill fits all pharmacology, it's one size fits all medicine. The idea of what pharmacogenetics is going to bring to the table is the right drug for the right patient at the right time. You just shift that to the right treatment for the right patient at the right time. And then finally, personalized medicine just stays personalized medicine, right? There was nothing inherently pharmacological in the personalized medicine. And so that just stays put. And so when you think of sort of this first decade of the 21st century, this is the golden era of personalized medicine. It is just exploding as a concept and as a way of packaging what medical genetics is bringing to healthcare. Okay, all that attention, though, ends up fairly quickly bringing some scrutiny. And there are basically three criticisms that come out during this era. It starts really you can find the earliest criticisms in 2003, 2004, 2005, but they just build as that decade goes on and as personalized medicine is getting more popular. Um, and I put a couple of books and articles in the top right-hand corner of this slide just because I wanted to mention, I know there's a lot of representation among Consilium Scientific's members in Britain, and much of the early criticism came from British sociologists of science. And what they pointed out was, on the left, these are just sort of quotes from academic articles that appeared during this period. On the right, I've got sort of more popular magazines and articles that talk about personalized medicine. And the image that is conveyed across the board within the scientific community and for the public is that what personalized medicine does is individualizes treatment, right? So take everybody on this call, if we've all got, let's say, diabetes, what personalized medicine is going to do is make sure that we each get our own special drug based on the fact that we each have our own special genome. And obviously, anybody who's familiar with genetics or pharmacogenetics knows that that's not how pharmacogenetics works. It isn't that we each get our own thing. It's you get stratified into different populations based on, say, your cytochrome P450 enzyme or one version of that. And, best case scenario, maybe 90% of us are taking the same diabetes drug that everybody else is taking, but 10% of us are put on some other drug, right? It's not individualized, it's stratified. You're just sort of grouping people based on their genomic profiles. And so that misleading quality, I think, was the first thing that really caught on and made people think, maybe this isn't conveying what we want it to convey. Another concern was that it was just offensive to people that didn't do genomic medicine, because built into it was this idea that if you weren't doing genomic medicine, you were doing impersonal medicine, right? The personalized medicine revolution idea was, look, we've got the Human Genome Project now. We're doing personalized medicine. And so the implication was, right, the endocrinologist, the surgeon, you name it, they're doing impersonal medicine. But obviously, that wasn't just offensive, it was enormously inaccurate historically. You can go all the way back to the Hippocratic corpus from millennia ago and find all sorts of advice to clinicians living in the time of Plato and Socrates to take the individual differences between their patients in mind when they're treating them for all sorts of different things. And so individual differences as a sort of relevant to clinical decision making is not new at all, right? And then just think about carrying that forward to the modern era, right? I mean, when transplant physicians are thinking about whether or not a kidney from a donor is a good match for a recipient, a lot of that takes HLA matching into consideration to make sure that the immune system of the donor isn't so radically different from the immune system of the recipient that their body's going to reject that organ. Blood typing, right? When an anesthesiologist is monitoring a patient who is undergoing anesthesiology or undergoing surgery, monitoring their blood pressure, their pulse, their oxygen levels, this is all personalized medicine, right? This is all people taking individual differences between patients in mind in the exact same way that pharmacogenetics would do it. It's just that they're tracking different things. And so there was also this, I think that the second worry is the medical genetics community was pissing off their colleagues across the hall in all the other disciplines of medicine because they were suggesting that you weren't doing personalized medicine unless you were getting DNA. And then the last thing that's worth emphasizing here, I'm coming back now to Daniel Nebert and Arno Matulsky again. Many of the the prominent sort of visionaries of pharmacogenetics at the beginning, shortly after personalized medicine starts to take on, really raised alarms about it being overhyped. This idea of a revolution coming, of a new paradigm, of all the problems in medicine going away now that we're personalizing it and getting rid of one-size-fits-all medicine. I won't read those quotes to you on the left there, but again, this is Nebert and Matulsky, the people who basically conceive of pharmacogenetics and bring it into the modern era with the cytochrome P450 research. Saying this is getting dangerous. It's conveying something that it can't deliver. I also put that article up there from one of your own, John Hickman, who was taking these very same lessons into oncology and saying, there's all this excitement about personalized cancer medicine. Who wouldn't want personalized cancer medicine? But when you look at the actual details of oncology and how it works, it's not living up to this promise. So, think of your sort of time machine back to 2010. What to do? There's this moment now where pharmacogenetics and now medical genetics more generally has been packaged as personalized medicine. Even within the medical community and the medical genetics community, there's this sense that something has gone awry. It is not, the concept is not conveying what the community wants it to convey. So what do? There is a world in a parallel universe where the decision was made that maybe the whole branding, marketing lingo exercise was the problem. That rather than saying, hey, this is, maybe pharmacogenetics isn't a very user-friendly term, but it does sort of convey this union of pharmacology and genetics, and we can tell you how that works. And so you just sort of stop trying to brand it and instead just sort of explain what it does in scientific terms. That world, I don't know, in some scientific sci-fi novel exists. That is not the world that we live in. In the world that we live in, the medical genetics community decided, or at least a sub portion of it decided, maybe it was just that particular branding. And if we come up with a different brand, that will get rid of the bad and bring the good. And that's what we get with precision medicine. So the first reference to precision medicine, at least as it's being used today, comes in this book that came out in 2009. But I think it got on the radar of most people in 2011 with a report that came out from the National Academies of Science, Medicine, and Engineering in the United States, in part because precision medicine, was built right into the title. This came out in 2011. If you didn't see that title and you just sort of skim through the book, you would think at that time you were reading a textbook in personalized medicine. It is paradigmatic personalized medicine. It's all about pharmacogenetics. It's all about differentiating patients based on their genomic profiles. There's primers on cytochrome P450, right? It looks like a personalized medicine intro manual, but they include this language where they say, this term personalized medicine has been misleading people. It's been making people think that each individual patient gets an individual treatment. That's not how it works. So we're going to use the term precision medicine. And so they introduce this term, and they also sort of make the case for what they want to draw attention to, right? So personalized medicine was about sort of each individual genome is a route to an individual treatment. With precision, the thought is, whereas medicine used to treat symptoms, precision medicine gets at genetic causes. And whereas medicine traditionally wrestles with diagnostic ambiguity and therapeutic uncertainty, with precision medicine, we're going to get genomic accuracy, molecular clarity, right? That's the motivation. It's a rebranding, but it's also an attempt to say, this is what we really want to draw out of medical genetics now as what's so revolutionary about it. And it turns out this becomes really catchy. This is now, again, sort of looking at what happens now, not in that first decade of the 21st century, but in the second decade even leading up to the present. Starting in about 2010 to 2011, references, citations to precision medicine just sort of are non-existent till about 2010, and then they just start to skyrocket. Journals in precision medicine are appearing. Some of them, again, think back to when we talked about this with personalized medicine. Some of them are brand new journals in precision medicine. Some of them are journals that were personalized medicine journals that are now being rebranded as precision medicine journals. Citations just sort of start skyrocketing from just a couple in the aughts all the way up to over 10,000 for the last year that we could get data from PubMed. You've got new conferences. Again, some of these are new precision medicine conferences. Some of them are just rebranded personalized medicine conferences. One of the advantages of the fact that personalized and precision both start with P is, in many cases, these organizations were operating on acronyms, and they didn't even have to change their acronym. So, sort of World Congress of Personalized Medicine can stay WCPM, and it's only in the fine print where you realize they've even sort of pivoted to World Congress of Precision Medicine. There's also, I didn't mention this in the previous, when we were talking about this with personalized medicine, but I'll say it now. Lots of university and hospital programs are popping up. Some of these are in med schools where they're teaching med students. Some of them are actual clinical services. Some of these were personalized medicine services, and now they're getting rebranded as precision oncology instead of personalized oncology. Some of them are just popping up de novo as precision medicine. Reporters are also taking notice, in part because this stuff was sort of directed at reporters from the get-go, the personalized medicine language. You see articles from reporters saying, hey, something weird is going on in medical genetics around sort of 2011 to 2013. We've been calling this stuff personalized medicine. You need to know the scientists are starting to talk about it differently. They're calling it precision medicine. So let's tell you what's going on there. Okay, so what I'm going to now try to convince you of in this section is those very same problems that were raised about personalized medicine. It's misleading. It's offensive to other clinicals and researchers who don't do genetics, and it's overhyped. Is still there with precision medicine. It looks slightly different for each one of those, but the gist of it is still the same. The same problems persist. Okay. And before I dive into those, what I want to do is sort of introduce you to these two patients who I talk about in the book, because I think particularly with Consilium Scientific's focus on patient experiences, patient outcomes, it's helpful to sort of remind ourselves, much of this talk I'm giving is about the scientific community, the clinical research community, evolutions in citation patterns and concepts over time. I don't want you to think that this is just a kind of abstract conceptual exercise. I'm tracking that, but I'm tracking it in part because I think this has a tangible impact on patients and their families. And so I'm going to sort of give you two examples to talk about what I mean here. So one is this woman, Marianne DeCanto. That's her on the left there with her husband, Scott Permiano. She was first diagnosed with breast cancer in 2003, had a pretty standard but quite invasive response to it. She has breast cancer running in her family, so this was not a huge surprise, but still, a really difficult experience. So she has a double mastectomy, radiation therapy, general chemo. That keeps her in very good shape for a decade. And then in 2013, it comes back metastatic. When they caught it in 2013, it had already spread to her bones, to her lymph nodes. It was all through her body. When she dives back into the world of cancer care in 2013, she now finds all these references to precision medicine. And so her and Scott are really heartened by what they're reading, right? It's basically everything that we were talking about in those previous few slides. Hey, cancer used to work by treating symptoms. Now we're getting at genetic causes. Hey, cancer care used to be suffering from uncertainty and ambiguity. Now we get clarity. Now we get certainty. But what they find is, as Marianne is making her way through her treatments, it is not a lesson in precision. So the first example they have of this is she goes and gets her tumors biopsied. The report comes back and says the drug Afinitor is going to be a good match for her. She's placed on Afinitor, and Scott has to rush her to the ER in the middle of the night because her red blood cell count had dropped catastrophically. They were worried that she was going to die. Anemia is a known reaction to Afinitor, and so it wasn't as if that people in the Afinitor prescription community weren't aware that this could possibly happen. But their understanding of how precision medicine worked was, you get this test, it tells you if this drug is a good or a bad match. It said this was a good match, so if it's a good match, how could this happen to her? The second frustration they have is then she underwent a series of biopsies over time. And what they found was they would send the biopsies from the tumors to different companies, and they would get reports back from these companies that told entirely different things. Different reports about what drugs were good or bad, different reports about kind of what genes they were tracking, different reports about sort of the status of her tumor. I think people in the oncological world know this isn't terribly surprising, but if patients enter this world where they're told this is precision, this does not look precise at all. And so, Scott, when we were talking, said this thing, things were getting more precise over time. They were getting less precise. And so it seemed like the more time they spent in the world of precision medicine, they were just absorbing these greater frustrations about how, in fact, it wasn't delivering precision. Marianne, basically threw her body and soul into precision medicine, very to the very end. She was going in for a last round of treatment based on a biopsy that she had received, something that looked like it was going to be a good target on Thursday, and she died 2 years later, or sorry, 2 days later. So that's an end of life story. Here's a beginning of life story. This is about Esme Savoy. That's her and her mom there on the right. So she was born in 2011. All sorts of really complex, profound developmental problems right off the bat. By the time she turns 2, her clinicians suggest doing some genetic testing. And what this genetic testing indicates is that she has a mutation in her PCDH19 gene, which is causing seizures, developmental delays, all sorts of gastric issues. So Hillary, her mom, basically goes all in on this PCDH19 diagnosis. She joins with other families that have children with PCDH19. She actually develops a foundation that's devoted to funding PCDH19 research in zebrafish. She starts attending meetings, sort of talking about her own child's experience and learning what's going on in the research world. As time goes on, though, they see, right, as they're spending years with these PCDH19 families, they can see that Esme is just not developing the way the other kids with PCDH19 are developing. And so 2 years later, they decide to do another round of testing. This round of now genetic testing says, remember that thing that we told you about PCDH19? It turns out that is not pathogenic. That's not your problem. Esme's problem is SCN8A. This is another even rarer gene associated with childhood epilepsy, seizures. This is the problem. So Hillary pivots. She now starts interacting with SCN8A families. She now starts going to SCN8A conferences. She sort of orients the Cute Syndrome Foundation that she developed to invest in SCN8A research. 1 year later, they do another round of genetic testing. This tells her SCN8A is also no longer pathogenic. We've got 2 new variants that we think are the problem. The last round of testing that she had undergone suggested that all 4 of those variants were actually now no longer the culprit, and they don't really know what's going on. And so Hillary talks about, in this process, uncovering or discovering what she called DNA's dirty little secret, that there is not this certainty and lack of ambiguity when you enter the world of genetic testing, that in fact these tests often come with asterisks attached, that sort of it's this is what we know right now, but keep in mind this might change. But that is not conveyed when what you tell people is this is precision medicine. So let's go through those things again that I mentioned before: misleading, offensive, and overhyped. The misleading component. The stories of Marianne and Esme are not unusual. Okay, right? The idea, the promise of what precision medicine is going to do is replace ambiguity and uncertainty with accuracy and clarity. When you look at how precision medicine actually works, when you look at how medical genetics actually works, that is not the guarantee, right? And there's all sorts of reasons for this. Variant reclassification is just a classic example. That's what was happening with Esme and her mom. I posted a slide there to a Concilium scientific presentation that you all heard about a year ago from Julie Eggington, which was basically all about this, how reclassification sort of leads to this imprecision. Different companies generating their own reports for different reasons that then gives patients different perspectives on what's going on in their body. There's also just the reality that particularly at the end of life, somebody who's metastatic stage 4 like Marianne, these aren't cures that are being developed, right? Typically what you're getting is best case scenario. If you've got a drug that might work for somebody, it's going to add a couple months to the end of their life. And so, the sort of idea of a revolution is really getting oversold there. And then there's all sorts of stuff just about, kind of the logistics of biomarker or biopsy capture, preservation, processing, which leads to all sorts of opportunities for variations and errors in that process that can then generate things in the results that are actually quite confusing. The main thing that I want to sort of draw attention to here is, though, I do think some of these things are probably functions of where medical genetics is right now. And so you can imagine a future not too far down the road, maybe 5-10 years, this could be the result of more regulation. It could be the result of just efforts to standardize things that aren't in place right now. Issues revolving specimen processing, certain standards for how these are conveyed, those could get better and make it such that those sources of imprecision are no longer there. But there are other features of medical genetics where this is just built in and they're never going to go away, right? We're never going to stop reclassifying variants. As long as genomics pushes forward, as long as we get bigger sample sizes, as long as we get more diverse sample sizes, variants are going to get reclassified. That's the nature of progress. That's not a problem. The problem is packaging it as precision, because what you get out of that is not increasing precision. It is something that is always going to be in flux. Like we saw with personalized medicine, there's also this risk here that it's offending clinicians and researchers in the same way that personalized medicine was doing that, right? So the personalized medicine claim was, if you're not doing genomic medicine, you're doing impersonal medicine. You've got the same thing going on here. If you're not doing genomic medicine, you're doing imprecise medicine, right? If you're not doing genomic medicine, you're not getting at causes, you're just treating symptoms. And again, if you look at the history of science, the history of medicine, it is all about identifying causes. Whether you're thinking about like the pump in London as the source of the cholera outbreak, right? Or blood clots and strokes, germs and diseases. This is the march of medicine, is the discovery of causes. It didn't start in 2000 with the Human Genome Project completion, or in 2011 with Towards Precision Medicine. Those just focus on particular causes. And I'll mention cancer here as just one example. If all we focus on is oncology, there are all sorts of different ways to treat cancers. There are all sorts of different ways to reduce likelihood of people in populations getting cancer, right? There are gene-targeted therapies. There is Herceptin, there is Tarceva, right? But you can also cut out solid tumors, use radiation. There's all sorts of chemos. You can use hormone replacement therapy, radio frequency, cryogenic, right? You can freeze it, you can burn it. You can put out public health programs that try to decrease the use of smoking. You try to get pesticides out of the environment. These things all improve population health when it comes to cancer, and they also improve patient health, right? If they sort of decrease the likelihood that cancer is going to emerge or spread. That works by getting at causes, right? And so the key here is that precision medicine doesn't get at causes in the way that endocrinology or surgery or public health, it doesn't get at causes. It privileges a particular kind of cause. And that's fine. I don't think anybody would want to say we don't want genetics in this mix, but we don't want to convey the thought that it wasn't precise until genomics came along, and it's only precise if genomics is involved. And then finally, we've got the overhype problem that just continues. The first thing to say is, the original hype language from personalized medicine never went away. You still can find, I bet if you did an internet search right now for precision medicine and miracle cure, you're going to get a news hit that came up in the last month. Breakthrough drugs, game-changing drugs, breakthrough treatments, revolutionary, paradigm-changing, right? All this stuff never went away when we shifted from personalized medicine to precision medicine. What happened, though, there was this like now extra layer of hype that got placed on top of the personalized medicine hype. Right. And that new extra layer was all about diagnostic clarity, right? Molecular accuracy. You now get these precision oncology on the sort of menus of featured services that hospitals are offering. And so there's this new bit of it that comes on top of it. I'll go back to Scott Primiano, with his experience in this world. I think the important thing to say was he didn't have any grudge against the oncologist that he worked with in his wife's treatment. He didn't think that oncogenetics itself was problematic. What he really didn't like was this precision packaging that gave him and Marianne the false hope that some sort of solution was there that it took time for him to realize never in fact was there. And so he tells this story about, whenever he's driving the car with somebody or around a living room and the television's on and one of these ads for a precision medicine center or some precision medicine drug comes on, he says, that is bullshit. That is not true. He gets that out because he feels obligated to say that. But he also says he understands that people don't want to hear that. They want the feel-good stories about a patient who's living longer. They want the thought that a revolution is just over the horizon. And he understands that this precision medicine language conveys that, and it makes people feel good. And he's very frustrated by that. So in the last minute or two, I'll just sort of try to wrap this up by then showing you kind of where we're at now and what and the confusion that exists, right? The first thing to say is there was this pivot, remember, back in 2011. Personalized medicine is creating confusion. What should we do? Okay, the motion is to switch to precision medicine. And lots of people made that switch. Journals repivot, conferences repackage, medical programs describe themselves as doing precision medicine now. But importantly, personalized medicine never went away. It wasn't like there was a vote and it was unanimous and everyone agreed just to stop using the term personalized medicine. This is partly a function of the fact that lots of groups didn't want to give up that terminology, right? It was on their letterhead, it was on their journal covers, it was on, it was how a patient blog was organized. And so they just said, we like personalized medicine better. The other thing to say is, and I think this is now where I'm particularly interested in how folks from Consilium Scientific or from outside the United States can share. Much of what I've been talking about was a very US-centric story. That pivot from personalized medicine to precision medicine really got magnified in 2015 when President Obama announced the Precision Medicine Initiative, because it signaled this heavy US federal investment in precision medicine. And it told the genomic medical community in the United States, if you want to get federal grants, you better start talking the language of precision medicine. But this stuff was going on all over the world. And if you look to Britain, to Europe, to other parts of the globe, personalized medicine stuck around much longer and precision medicine caught off much slower. So what's happened is, since 2011, since Toward Precision Medicine, we continue to get new journals of personalized medicine. They've never gone away. Citations to personalized medicine continue to climb. They didn't slow down, right? I've got that Google Ngram there at the bottom again. Now it just sort of shows not personalized medicine ending in 2010, but going all the way out to 22 right there with precision medicine. And what you can see is it went up. It's kind of tapered off a little bit, but personalized medicine is not going anywhere. Right, it is out there. It is in full effect in the same way that it was before precision medicine ever came along. So, what to do? Well, it turns out there were sort of two responses to this, and each of these I'm going to try to convince you of aren't particularly good. This takes us back to that very first slide. One solution is to try to impose some artificial distinctions on these concepts, right? And it turns out if you're looking for these artificial distinctions, as each author who you find will sort of carve it up a little bit differently. And that's why those first quotes I gave you way back when, right? Personalized medicine is the overarching concept. Precision medicine is a subset. Precision medicine comes first, personalized medicine later. Precision medicine does this, personalized medicine does that. Each of these is different, because each of them is basically just manufactured. There's nothing tethered to reality that suggests one of these is better than the next. It's just efforts to try to kind of impose some order. And so each person comes along and imposes their own order. The problem with this approach is when patients and families, when lay people that aren't familiar with this world come into the space, they can basically get completely different versions of events, right? So they can sort of read online that when they sent their DNA to 23andMe, that was personalized medicine, but when they get to the clinic, it's going to be precision medicine. And then go into the clinic and have a clinician tell them, we're going to do personalized medicine first with this and this and this, but then we're going to give you precision medicine later when we give you this particular treatment, right? There's no way to kind of align these any particular way because they're artificial and manufactured. The other strategy, and I would say this is the more historically accurate one, is just to say these things are synonyms, right? And you see lots of references to this. Personalized medicine, also known as precision medicine. Precision medicine, variously known as blah, blah, blah. This is the thing that you hear more often. And again, I think that makes sense because they were introduced as synonyms. Precision medicine was introduced to say, this means that, we're just worried that it confuses, and so we're going to do this. Of course, the problem with this solution is precision medicine was introduced to get rid of confusions about personalized medicine. And now when you say personalized medicine, also known as precision medicine, or precision medicine, also called personalized medicine, you're basically bringing with it all the problems of personalized medicine and then layering on top of it all the problems of precision medicine. So you've compounded the confusion. You've made it twice as worse as it was in 2010 when you were trying to clean up that problem. So this is my last slide. This is the take-home lesson for me. This is what sort of I recommend, and although I'm happy to sort of hear what other people think about it, I think the solution is just get rid of these terms. Enough of the marketing lingo. Precision medicine, personalized medicine, they were designed from the very beginning to be marketing lingo. They have created confusion. We should stop using them. There is plenty of, there is plenty of language available to capture what's going on here. And we've always been using it as well. Pharmacogenetics, gene therapy, genetic testing, molecular genetics. The language is out there, right? It might not be as snazzy. It might not seem as super cool as personalized medicine and precision medicine. But I think the lesson is there is a serious trade-off with the snazziness and the super coolness, which is that it misleads and it offends and it contributes to this overhyping. And so I think getting rid of the terms and just sort of let the revolution speak for itself based on the results is the better solution. And with that, I'll say thank you. I'll turn off my screen and say that I'm looking forward to speaking with everybody.
Thank you so much, Jim. So please turn on your cameras and raise your hands if you would like to ask a question. And James, there was a question in the chat, which I also had that question while you were talking, about AI now changing the world, how you think that might impact the precision medicine, and obviously there's another spin of hype coming in from that direction that we so what are your thoughts on that?
Yeah. I think with many things, AI is not the existential threat that some people, I don't think we're heading for the Terminator scenario where the AI bots kill us. I also don't think it's going to deliver all the promises that are out there. AI, machine learning, it's a powerful data analytic set of tools. It's opening up opportunities that weren't there before. But I don't think it's going to solve the problems that we're talking about here, right? Variant reclassification isn't going to go away as a result of AI and machine learning. We might reclassify them quicker, but the fundamental biology isn't going to change. I think these issues, the fact that medical genetics doesn't truly personalize, individualize medicine. The fact that medical genetics is constantly evolving. These are features of the biology, not the tools that we have to work with. And so they might make it work better, but I don't think it's going to make these particular problems go away.
I think the follow-on question is, do you think any lessons have been learned from the perspective that I might be wrong, you're definitely more in the subject, but there seems to be a huge disbalance of overspent into personalized precision medicine and the resources being diverted towards this agenda, which probably to begin with was not a malicious intent. I think people genuinely thought that this is the future of medicine, and who knows, maybe one day it will be. But the investments have been huge, and looks like now there is a new kid on the block with demand for very similar hype and investments, diverting resources from collapsing healthcare systems around the world. So how do you think this message should be voiced louder? How can this be dealt with, resolved with?
Yeah. The first thing I'll say is I agree with you. I don't think there are any nefarious actors in this story. These are all people trying to make the world a better place, and I think that's important to say. I don't think anybody was sort of up to no good. I just disagree with kind of the way they went about it. I'm certainly trying to be a voice in that space, but it will take time. I do think there is reason to think that the dynamic is changing a little bit. So, there's a way in which the company 23andMe has always been symptomatic of sort of where this space of medical genetics is. It came out in 2007, fueled on the promise of personalized medicine. And it was a billion-dollar company. There were spit parties. It was an Oprah giveaway, right? I mean, like everybody wanted to get in on personalized medicine, and 23andMe in some way sort of captured that. Within several years, they realized the real promise here isn't personalizing healthcare for everybody who spits in a tube and sends it to us. It's in the data. And then they start making data agreements with pharmaceutical companies. And much of medical genetics has gone in that direction. It's less about sort of delivering health benefits to the people that give you their DNA and more in trying to get larger and larger data sets to look for rarer and rarer variants. And now 23andMe is basically, it's down to a penny stock. The chances of it being around much longer, at least in its current form, are very rare. And I think that also sort of speaks to at least the way medical genetics was sort of packaged to the wider public is no longer sustainable. And so I don't think it's that it's going to go away. I just think what we're going to find is it's going to get a little more nichey, right? So if you're interested in rare diseases, it would be very unusual if you were interested in genetics. If you're interested in cancer therapies, I think, again, genetics is never going to leave that space. But I also think that some of the other places that people were super excited about medical genetics revolutionizing, let's say psychiatry, all sorts of public health domains, there is a retreat there, and it's becoming clear, we can run bigger and bigger genome-wide association studies, but the payoff of that isn't going to be the promise that we were getting at the beginning.
Thank you. Charlie.
Are you able to hear me?
Yep.
Yeah, loud and clear.
Okay, so I'm an oncologist, so I look at it from the oncology framework.
Good.
A lot of we think in oncology is sort of like we're a hammer and everything's a nail. And so this is the hammer nail thing. And that's why we sell these products wherever they can call any one of the names you want. But in oncology, we have many ways to think about a cancer. We talk a lot about the seed and the soil theory. So to the extent that you believe the seed is the issue, then biopsy all you want and gene test all you want and personalize and precision all you want. But if in fact it's a soil issue and not a seed issue, which is probably the majority of oncology, it's like Willie Sutton looking for the money or the keys where the light is because it's more light out rather than where they actually are.
Right. Yeah, no, I agree. I mean, this point goes by many different names, right? The drunk looking for their keys in the light. If you got a hammer, everything's a nail. The worry is you've sort of got this powerful tool, which really does work in some situations, right? But now you're over applying it. And that's right. I think I had that whole list of sort of interventions that you might have available when you have a patient with cancer. Gene targeted therapies are one of those, right? But it is hard to think of something that's had a greater impact on cancer than just smoking cessation programs, right? I mean, like that has been enormous. Getting asbestos out of our environments, reducing pesticides. These have had tremendous population level impacts on cancer rates, and that's, I think, what we just need to be mindful of, right? Sort of what do we value? Are we trying to drive down these population level rates? Are we trying to make sure that that very well off person, when they get cancer, sort of has lots of things to throw at them at the end of life to give them a couple more months? It's fundamentally a question about what society values, although I just don't think that your average person on the street knows that sort of the things that they value, like the promise of a revolution, the thought that this is going to be some wonderful new way of practicing medicine, might actually be siphoning resources away from other approaches that could be much more effective.
Thank you. David, please go ahead.
Yes, I'm surprised you didn't mention Stephen Sen's writing about this, because statistically, it's very difficult to show that personalized medicine actually works, as he's pointed out at length.
Well, I guess it depends on what you mean work. So, I opened the book that Lisa mentioned, the story of my father, who had non-small cell lung cancer, metastatic when he was diagnosed. He was put on Tarceva. He lived for 13 months. This was at the very beginning of like the targeted therapy Tarceva era. And at that time, I can still remember sort of sitting in the ICU doing a Google search for stage 4 non-small cell lung cancer. How long is my dad going to survive? And it looked like a couple months, right? I have no doubt that my dad lived longer because of that Tarceva. And I think there's lots of cases like that. There's also, by all accounts, success stories like imatinib for chronic myelogenous leukemia, Herceptin for breast cancer. There are things that let people live longer, and I think that's a good thing. But I would rather my dad not have had lung cancer. And that's not a story about Tarceva. That's a story about where he grew up. It's a story about where he worked. It's a story about decisions that he made over the course of his life. And so for me, it's less about sort of does it work and does it not work in the whole, and more about are there places where it's getting some purchase, and where are those and where are those not. Thanks, David.
Joel, please go ahead with your question.
So I'm just wondering how much you think that the pharmaceutical industry, with its use of the terms precision, personalized, etc., is contributing to the hype around the supposed benefits of the drugs that are being developed.
I think pharmaceutical companies are a part of that story, but it's not exclusive to them anymore. When I go up to the med school here and talk with genetic counseling students, they talk about precision medicine, and get angry when I tell them that maybe that language isn't the best way to describe what they're doing. Right. When the president of the United States says we're going to have a precision medicine initiative and we're going to be funneling millions and billions of dollars into this, that's not pharmaceutical money. That is a public sector saying this is how you need to characterize what you're doing. And so I think pharmaceutical companies are part of it, but I wouldn't want to, sort of make it sound as if the only thing that's guiding this is kind of crass financial interests. And when we get away from Pfizer and Glaxo, we don't see it. This is bigger than that. I think it's tapping into something deeper. It's tapping into this sort of more, I think, human desire for delivering something that's personal, for delivering something that's priced, for believing in a future where what you get is personal and precise. And I think that's more than just finances.
Thank you. Indeed, Jim's book, we didn't talk about it much today, but it's not about pharmaceutical industry, and I thought it would be. So, and it was completely an eye-opening story of what was going on in the UK government and the decisions between the institutions and actually academic medicine. So absolutely fascinating read, and I suggest you take advantage of it and learn something from James's work. So thank you so much, everyone, for joining today. Thanks so much for a very insightful, very interesting talk, Jim. And we'll see everyone in 2 weeks. Have a good evening and afternoon, everyone. Bye-bye.
My pleasure. Thank you.